There we go. Okay. Here we go. I think I got it figured out. Connor, can you hear me? Connor, can you hear me, my friend?
Miss Kulak, please call 3215.
Perfect. Can you see my screen?
Call 3215.
Perfect. You can see my screen. Perfect. So I'm just going to let everybody file back in. We're going to get started. So we're talking about the domains and ranges here. Okay, so x values. It's going to go on and on forever and ever up that way, right? So what do you think your possible x values are going to be?
I put all numbers in line out of line segment.
All numbers. Because, very good, nice job. Because this is going on and on, it's going up like this. And keep going that way and that way. It's going to hit all the way out to infinity with those little arrows up. So it's going to have a domain, x values of all numbers. Good. Okay, I think we're good now. I think we got it figured out. So we're talking about domain and range. Good. Now our range talks about our what values? Gwen? Y values. So there's going to be a little bit of a constraint on our y values. What is our range going to be for this guy here? What are you thinking, Gwen? 0 to infinity. Good. So all numbers greater than what number? 0. Very good. Okay, so for my friends that are at home, I know that this is sort of a different take on how we've been talking about domain and range, but because I sort of was we were over ambitious in the way that we presented it, where we presented it as writing them in with inequalities, that was a little bit too high above the standard that you guys are supposed to be at. So we're taking it a step back and we're just describing them with sentences, okay? We're going to do a lot more practice with this because we need to sort of take it back. So don't feel like if you're not understanding it at this point, you are lost, because between now and the end of the unit, we're going to do a new one of these. We're going to talk about domain and range every single day. So we are going to talk about domain and range again today as well, okay? So let's take a look at 3, okay? This is where today's real new learning is coming in. So a self-service frozen yogurt store sells servings of frozen yogurt up to 12 ounces. So you can buy up to 12 ounces, that's it. It charges 50 cents per ounce for the first serving between 0 and 8 ounces, and $4 for every serving greater than 8 ounces and up to 12 ounces. Okay, from 0 to 8, it costs 50 cents per ounce. Then from greater than 8, it's going to be $4 for everything between 8 and 12. Choose the graph that best represents the price function of the weight of a serving of yogurt. Be prepared to explain how you know. So I want you to take another 20 seconds to look at these graphs and decide which one of these graphs represents this story, and then we're going to come back and talk about it. I know you guys had an opportunity to look at it, but I want to let friends at home take a minute to look at these as well. I think when you look at it, it's going to be sort of, I don't want to say obvious, but it'll be clearer what it should be. But I want you to take a few moments to take another look at it if you didn't get a chance to do it. If you did, we're going to take a look at it now. Okay. So we're looking at these 4 graphs here, A, B, C, and D. Which one of these graphs did you feel represented this story based on the story that we have here? Kyle Kelly, which one were you thinking? B. Okay. Did anybody get a different one? Someone else who got B, tell me, why did you choose B? John? Or were you scratching your ear? Scratching your ear. You were deceiving me. You were scratching it for a long time. Gwen.
I said B because if you look at it, for every one it goes up half a block. So once you get to 2, it's $2, which is the story. But then when you get to the 8, it becomes $4, and you can move those $4 as well.
Mhm. Good. So we have sort of two different intervals, two different things that we're talking about here. So from 0 to 8 ounces, we have a rate of change of 50 cents, which if you look at this first segment, we are going up half a block for every one we're going over. So that meets that first segment. And then at 8 ounces until 12 ounces, it's a solid $4. So we have an even off piece here. So it's two pieces that are described in this graph because we have two different rates of change that we're dealing with, right? Does that make sense? Does everyone see why we chose B for this guy here? Wonderful. Because it's not only just increasing like A and D say, and it's not staying constant the whole time like C, it's a mixture of both of those scenarios. Okay, nice job. Let's look at our targets. Okay, our targets for today. Number 1, I can make sense of a graph of a piecewise function in terms of a situation and sketch a graph of a function when the rule is given. Okay, we're going to be making some graphs today with some piecewise functions. And we're going to be able to look at graphs and sort of understand what it's telling us. Then we're going to be able to make sense of a rule of a piecewise function when they are written in function notation and explain what they mean in the situation. So we're going to be given a graph or maybe a rule, and we're going to have to write a piecewise function for it and then talk about what each of the pieces means in the context of the story. And then we're going to be able to make a function or understand what makes a function a piecewise function. Okay. So let's slip and slide down to slide number 5 right now, where we're going to look at this new term, not the newest of new terms, because I've talked about it before, but today we're going to put a definition to it, and we're going to look at in depth what it means and how we write them and how we represent them in different forms, like on a graph, in a written explanation, and in function notation. So a piecewise function is a function defined using different expressions for different intervals of the domain. So we have different segments of our graph for different x values, domain values, okay? So if we look at this example that we have here, we have 3 separate segments here. 1, 2, and 3, okay? When x is less than 2, it gives x squared. So for every value less than 2, you're going to have this expression, this equation here, this x squared. And it says less than, so it's going to be an open circle. Then when it's exactly 2, it gets you 6. So that's this closed dot on the y equals 6. And then when x is more than 2 and less than or equal to 6, the line is x, 10 minus x. Okay? So for this interval right here, we have an open circle because it's more than 2 and less than or equal to 6. So we have a closed dot. That's how we take this explanation here, and we're going to graph it. Now, when we write in function notation, we say f of x or g of c, whatever the name is equal to, and then we put a bracket here. That's bad, but whatever. We put our 3 equations that we have here and the intervals in which they are on our graph. So when x is less than 2, we have this equation. When x is equal to 2, we have this equation. When x is greater than 2 but less than or equal to 6, we have this expression here. Okay? We're going to skip the domain and range part of it because we're going to talk about that in the next activity. So piecewise, meaning it just has a bunch of different sort of segments to it with different rates of change. Okay? Moving forward, let's take a look. Okay, we're going to look at postage stamps. Okay? We're going to look at postage stamps. The relationship between the postage rate and the weight of a letter can be defined by a piecewise function. Because for different weights, it costs different amounts. Okay? The graph shows the 2018 postage rate for using regular service to mail a letter. Okay? Your job, first and foremost, is to determine what is the price of a letter that has the following weight. 1 ounce, exactly 1 ounce, 1.1 ounce, and 0.09 of an ounce. I want you to take 1 minute right now to use this graph right here to determine these 3 prices using this graph right here. Remembering the dots, what those dots tell us. Take a minute and a half right now to determine these 3 prices. And then if you finish early, you can take a look at number 2. Nice job. Wonderful, wonderful. We're taking another 26. We're not rushing today. We're taking our time, trying our best. Looking at number 2, if you get through the first one. Nice job, Peyton, on those 2 answers there. Nice job. And I like that about. Nice job there. Okay, take another 10 seconds to firm up your thoughts. Take another 10 seconds to firm up your thoughts. Okay, so this first one is probably going to be the harder one of this question set here. People at home, let's get some answers in the chat, please. Because I have one from Gabe and Peyton. I want to see some other people active in that chat. Let's go. 1 ounce. So if I'm looking for 1 ounce, which axis am I going to look on? Kyle. Because why do you say that? It shows the weight in ounces. Good. So we're going to look for that 1. I have 2 points that fall on that 1 line. Which point did you use there to determine it? Junior. Why do you say that? Because it's less. Okay, so you're thinking logically in the context of the story. But why does the closed dot represent the one that you're going to choose? Kyle. Or equal to. Because this guy here is on 1, but it's an open dot, so that means it's not equal to 1. It's going to fall everything above that 1. So the 1 is going to be, if you have a point on where you have multiple points, you're going to go with that closed dot point. So how much is 1 ounce going to cost us? 50 cents. Very good. You could have written 0.5. I just wrote 50 cents because that's how he said it. Now, 1.1 ounce. Max.
I put about 0.72.
0.72. What else are we thinking? What are some other values that we got? Somebody at home said 0.76. Do we agree with that value? John says no. Why do you say no to that, John?
Because the line is under 7.75.
It's under the 0.75. Good. So I wouldn't accept that. But what are some other numbers that people had here? 0.72, John?
0.73.
0.73. I would also take, Kyle Kelly, do you have a different one? 0.7. Yeah, I take it. 0.7. I also would take 0.71. The actual value is 0.71, hint, but I mean, it's not a big deal. You can put all of we're talking about this segment of the graph here. 0.9 ounces would be how much money? Kyle Kelly? 50 cents, because 0.9 is going to fall between here, which we know is going to be 50 cents. Very good. And then you could also write it as like 0.5. Nice job. Very good, Abby Wasta. Okay, so I'm going to just leave it as 0.71 now. But know that if you had something within that range below the 0.75, I would take it. Okay, good. Now, a letter costs 92 cents to mail. 92 cents. So what must be the weight of the letter? John, what were you thinking?
Between 2 and 3, but not including 2.
So between 2 and 3, and then what would be my label on that? 2 and 3 ounces. But, and then he also added, but not including 2 exactly. And I would say, I would phrase it as 2 exactly. Between 2 and 3, but not including 2 exactly. You could have said like 2.5. I like this answer though, because it's giving me a range of values that it could be. Very good job there. Awesome job there. Does everyone see how we got this value right here? Because we said it was going to cost me 92 cents. So which one of these legs, I'm going to call them legs or segments, is talking about 92? It would be that 1, 2, third one here, which falls between this 2 and 3. It's an open dot on that left end, so it would be not including that too. Good. Does everyone see how we got that answer there, guys? Friends at home? Okay. Very nice. Like I said, we're taking our time. If we're not understanding, we're letting me know, and we can slow it down. Because I think piecewise, I think this year we've done a really good job leading up to this piecewise unit. So I don't feel like it's going to be super duper. But if you need me to slow down, please let me know. Okay? So now it's your turn to take a look at and use this graph. Okay? And we are going to look at 2 different piecewise functions that Kai wrote and Kai and Mai. So we're going to look at these 2 piecewise functions here, and I want you to identify the errors in each one of those sets there. Hi, this is Mr. Main, sorry. Oh, okay. Okay, perfect. Wonderful. So I want you to take 1 minute right now to look at and see if you can identify the error in each one of these. Each one of them has a slight error. Hence, the cost of the intervals is correct. So don't be like, oh, it's not 92, it's not 71. No, the costs are correct. It's something different that's wrong. And I'm going to talk about that when I go there in a minute. Okay, we're taking another 10. Okay, Take 10 more to firm up those thoughts. Take 10 more to firm up those thoughts. Okay. So if we're looking at Chi's piecewise function here, it's written in function notation. What do we think was wrong with Chi's description here? Kyle Kelly, what were you thinking?
That's the greater.
Oh, so there's something wrong with his, what are those called? Inequality symbols. Yes, nice job, Cindy. So the right side inequality symbols. Oh, the left side? Oh, the left. Okay, you're right. Mr. May. The left side inequality symbols. Good catch there. And what was Mai's error? Max?
That she didn't put or equal to. That she didn't use or equal to inequality symbols on the right side.
Didn't use or equal to symbols on the right side. Did anybody have any different errors that they thought there might have been? Anybody have any different things that they noticed? No? Okay. So now it's going to be our job to rewrite this piecewise function. And I want to go back for 1 second and I want to review how we write piecewise functions. So if we come back here with the piecewise functions, each one of these lines of the piecewise function has to have two pieces on it. It has to have the equation, or in this case, the value that it's going to be equal to. And then it has to have the interval written as an inequality. So now I want you to go through and I want you to correct this this piecewise function here, and we're going to name it P of, we were using W. Okay. I want you to rewrite this inequality, making sure that you're putting commas after the equation piece of it, and then writing the intervals using the appropriate symbols. I'm going to give us another minute and 30. Taking another 37. Great. Take 10 more to firm up your thoughts. Take 10 more to firm up your thoughts. Nice job, Gabe. That's not a problem. Okay. So let's take a look at let's see what people are thinking for this first one here. So the first thing we need to write in the first part of this box is the equation, or in this case, the value that it's equal to, like the y is equal to, and what's it going to be equal to for the first interval here? Max.
0.5.
0.5. Okay, and then we put a comma, and then we write the interval, the domain intervals that it falls and going to be equal to that value. What is the domain intervals that it's going to be equal to that value? What did you put there, Max?
0 is less than, W is less than or greater or equal to 1.
Okay. What do we think about this that he wrote here? Do we agree? Is there anything that we would change about this? I need eyes up and up here. What do we think? Looking at just this first interval, this first piece of our graph here. Do we agree? Why did he do his symbols the way that he did? Why did he do a not or equal to on that first piece there?
The first dot is
Open, thank you. Very good. It's an open dot, so he didn't put the or equal to. He could have, and then he put the or equal to under that one because it is a closed dot. Very good. You could have also written it as 0.50 because we're talking about cents. That means the same thing. Nice job there, Peyton. And I'm going to actually change it to that. I like it. That's more precise. Good. Now, second interval, the second sort of piece of this graph here. Remember, we said that value that it's equal to is correct in this table. Who can help me to write the second interval for this piece here? First, the equation or the value it's equal to. What's it going to be? Junior.
0.71.
And then 1.
Is less than, less than or equal to.
Good, because we go from 1 to 2. That's why we chose those two values. The W falls between it. And we're going to say a not or equal to on this first one here because it's an open dot up there. This end piece, this top of the range here is a or equal to because it's a closed dot on our graph. Very nice job, Junior. People at home, do we agree? Is there anything that we would change? Nice job there, Ian. Anything that we would change? No? Okay. Sadie, can you help me with the third interval here?
So
0.92, good. And then my comma, good.
2 is less than W is less than
Okay. Once again, she put that less than first because it's an open dot, less than or equal to because it is a closed dot. Very good. Or the 2 is less than or equal to the W. Very good. Or less than. Last segment here. A little bit of a trickster. How do we write this last segment here? Junior?
1.12, comma 3 is less than 70.
3, yep.
And then it's less than or equal to.
And why did you say first? Why did you write 3.5 instead of having it be a whole number like all those other ones?
Because there's a closed open dot on 3 and a closed dot.
Good. So that last segment was a little bit of a trickster because it wasn't a full one long. So we have a 3.5 as our top gap there. I mean, our top range value there. Nice job. Very good, very good, very good. Awesome job, my friends. I'm gonna leave this up for another 15 seconds in case you need to write this down. In the meantime, I want you to ask me, do we have any questions about this? Were you unsure of why we did anything? Are we confused as to why we chose the symbols we did? No questions? Okay, so I'm gonna give another 10 for you to write this down in case you didn't get it written. And then we're gonna move forward to the next piece of this. Next piece of this is we're going to be creating some tables and we're going to be creating some graphs. It's going to be fun. Questions?
What would you ask if it would still be correct if you wrote it backwards, like 1 is greater than or equal to W is greater than?
As long as like the alligator's eating the right one, I would say yes. But usually we like to work the way that we read a book. But if you want to go backwards, I would still accept it. Good question. Perfect. Thank you so much, Abby and Gabe, for that. Okay, here we go. Let's move forward. So we're looking at 8. Okay, 8, we're looking at a different scenario here. This time we're given the piecewise function and or like written in the function notation, sorry. And we are going to be looking at a scenario, a function that's representing the dollar cost of renting a bike from a bike sharing service for T minutes, where here are the rules describing the function. Okay, so it's 250 and T is representing time in minutes. So from 0 to 30 minutes, and then we have our other intervals down below. I need you guys to do one of two things. I want you to first, number 1, complete this table with the costs for the given lengths for the different lengths of rental. So if you rent it for 0 minutes, how much is it going to cost? 10 minutes, 25, 60, 75, 130 minutes, and 180 minutes. I need you to take a minute and a half right now to answer these 7 values here. Find those costs. Think logically. You might need to think logically for that first one. Not that you don't think logically. Okay. If you finish early, which you don't need to rush to do, we're going to be creating a graph on slide number 9 next. You can start to think about how you might graph it. Take time. Don't rush. Okay, take 10 more seconds, firm up those thoughts. Okay, 5 more seconds, firm up those thoughts. Okay, 0 minutes. How much is it going to cost you in dollars? Making sure you're looking at those symbols. Kyle Kelly. How much? Yeah, because we're saying it's not or equal to 0. Good. So it's going to be $0 because it says it's all the way up to 0 minutes, but not including the 0 minutes. If you're looking at that symbol, that was probably the trickiest of the trickster questions in this table here. You had to look at those symbols. The symbol down here on the left bottom edge of this interval here is telling us it's not going to be or equal to the 0. So 0 is going to be $0. Good. 10 minutes. How much is 10 minutes going to cost me? Kyle? $2.50. Very good. How much is 25 minutes going to cost me? Gwen? 250. Gabe, how much is 60 minutes going to cost us? He says $5. Do we agree? Why? Or equal to, very good. 75 minutes. Kyle? $7.50. Okay. Sadie, 130 minutes. $12.50. Do we agree? Do we disagree? John's shaking his head. Yes, you agree? Perfect. 180 minutes. Gwen? $15. Oh, I forgot a decimal point. I was gonna say, why is that such a big number? $15. Good. Very, very, very nice. So my suggestion to you, what we're gonna do, what I want you to do, so we're gonna get started on this before we head out. I want you to click on this guy here. I want you to copy him because we're gonna bring him to the next slide and we're gonna use it to create the graph, okay? So I'm gonna come down to 9. So you take it to 9, you paste it in, and we're gonna create a graph based on this piecewise function here. Okay. So I have on the right-hand side here, I have some closed dots, that's these pink guys. I have some purple guys, which are open dots, and then I have some yellow line segments that we're gonna use to connect them. Okay, you see that? So let me grab my chair. And we are going to create the first 2 segments together, and then you're going to finish up and finish this graph to create the second the last 4 segments. So I'm going to create this 2.5, this first interval here. What kind of dot am I going to grab to put down first? Sadie? Why do you say that? Very good. Less than, but not equal to. And you put it on your 250. Good. And then what kind of dot am I going to grab for the end of this little segment? Very good. A closed dot because it's or equal to. And where am I going to go to get there? Over to 30 and where? Up to 250. Very good. And then I'm going to grab a little seggy off here. Line it up with my open dot. Swing it up to hit this guy here. Maybe I'll have to bring him up a little bit. Boom. Listen, it's probably not going to be perfect. It's a little bit tricky. I get it. It probably isn't going to be flat, but we're going to try our best. Okay. See, I couldn't make it flat for some reason. So awesome. Now we're going to do that second segment. Who can help me grab that second segment? Gotta enunciate my words here. What kind of dot am I going to grab? Gwen? An open dot. And where am I going to go? Over to 30, up to 5. Good. Then I'm going to grab a closed dot. How am I going to get there? Over to 60, up to 5. Close, drop it down. I'm going to grab my liney poo. I'm going to put it there. I'm going to swing it up. Once again, it's probably not going to be straight, but it's implied that it's going to be straight because I don't know why it's being silly dilly. Now what I want you to do is I want you to take the next 2 to finish creating this graph using these symbols here. Using these circles, using these lines, making it as straight as you can, but knowing that it probably won't be perfectly straight. Take 2 minutes, let's do this. think about what you're gonna do for the end, that last segment. The last segment might be where the trickster comes in. No trickster for you? I love to trickster people. Cool. Taking another 5. Here we go. I understand we're at Spanish time. We are going to be taking, I need like 10 more seconds of your time, and then we will go into Spanish. Okay, so I created my graph for the next 5 intervals. So I got up to this last guy here. That's where I sort of hit a snaggy poo. Because I have 15 is my value here, and it's from 150 to 720. So what kind of point did you put down at the beginning of the left-hand end of this interval here? Max?
I put an open point.
You put an open point at, how did you get it? How'd you get there?
I went to the right to 150 and I went up to 15.
Okay, and then did you put a dot on the end, like, because you're taking it out, right? And it goes to 750. So did you put a dot at the end of it?
No,
Why did we say no on that?
because it goes up to 750, so it wouldn't fit inside the segment that we can see.
Good. It wouldn't be on this segment of graph. The endpoint wouldn't be on the segment of this graph. So you're not going to be able to put an endpoint on there. So I would, if you were to put an endpoint on there, if you did put it on there, you need to take it off because that's not the end of the interval. You only put the dot on the end of the interval. Because it goes out to 720, you would have to put the dot at the end of the 720. Because 720 doesn't fall on this graph here, you're not going to put a dot on it. Good. Okay, listen closely. The end date on this activity is Sunday. It's due Sunday. We're going to finish up the last bit of this activity tomorrow. Your homework this evening, listen closely. Okay. I'm gonna have you do that link in 1 second, but your homework for this evening is on slide number 13. We're gonna work on activity, piecing it together. Okay. Piecing it together is on slide 14 to 16. And so 14 has the directions, and you're going to use this the piecewise function given to you on here. You're going to rearrange these pieces to create this piecewise function down here, and you're going to use these dots to put on the ends of these segments. The segments, the equation lines are these pink lines here. These firm black lines here are your axes, your X and your Y axis. I want you to give it a shot. This is probably going to be a little bit tricky. We're going to go through it tomorrow, but I want every single person to work on this today for homework. So slide 14, 15, and 16. 14 has the directions. 15 and 16 have 2 puzzle pieces that you're going to try to match up and create the piecewise function listed on the slide. Like I said, we're going to go through it. What I want everyone to close with for today is I want you to, there's a link on slide number 10 where you're going to be watching a video and you're going to be guessing how many crayons on that Google form, how many crayons are in here.
That's
If you click it. So it's like, because this is going to be our lesson for tomorrow. You're going to be we're going to be using this data to talk about guesses of how many crayons are in this jar. I put a video in here for the friends at home that can't see it. If you want to watch it and take a guess. Yes, so you can go to Spanish. Wait, do you guys have a live stream today? Are you live streaming? Oh, sorry, I'm so sorry. You guys can go to Spanish. Go to Spanish, go to Spanish, go to Spanish, please. Go to Spanish, go to Spanish. Sorry, I thought you guys weren't live streaming. People in here, people who don't go to Spanish, I need you to guess how many crayons are in this container. Don't go too big. It's not like 100. I sideways.
47.
Top, I mean, the top is
Back starts.
No, I'm saying that there's too many.
do not count. That's
And
cheating.
That's
Cheating. Simple, simple. Just take a guess.
a lot of things.
A lot. A lot, but not too much.
I feel like under 50.
Okay, so my friends, if you are at home, if you are in school, I need you to bathroom, fill out the pass. I need you to jump into, wait, today's Thursday. I'm gonna check Alex times. I need you guys to jump into Alex. I need everybody to jump into Alex, and then I will let you know if you are over your time, and you can work on something else. So everybody needs to jump into Alex for me, please. Oh, Adam, perfect. I'm gonna go to this tab here. Oh, that's not Alex. Reports, time and topic. I'm gonna change my date range to the 15th. Okay. Connor Jr., if you would like to work on something else, you can. Maybe you can work on the homework, the piecing it together if you want, or anything else. John, can I get like, yep, you're good. You can jump into something else. What it has to be school related though.
Okay.
Huh? Yes. Sadie, you are good on time and topic. So if you'd like to work on either homework or something for another class, you can do that. Kyle Kelly, if you'd like to jump into, when he comes back, I'll let him know. Max, if you'd like to jump into something other than this, you can. Maybe the homework. Adam, you need one more topic, Adam. So I would say stay in because I need you to get one more topic done. Cameron is in Spanish. Ian is in Spanish. Tyler should be in here. Yep. So Tyler, you need 1 more minute. I want you to finish the knowledge check. Finish the knowledge check for me, please. Gwen, you still need 2 more topics. Peyton, Nassim. Oh, Nassim is almost there. I want you to try to finish that knowledge check for me, Nassim. You're doing great. Abby Wasta is in Spanish and Ava's in Spanish. Kyle, if you'd like to, maybe you want to do the homework, the piecing it together, or you can read, whatever you want to do, because you have your time and topics done. It just might be a good idea to get that homework done, but that's just me being me. Let's take a look at responses. Oh no, did I lose my Zoom? No, I didn't.